Chapter 2, Lesson 4, we're looking at reasoning in algebra, beginning to develop proofs and reasons for what we're doing. We've talked about how to reason in algebra from step to step. I want to talk about some properties of congruence in this lesson. Properties of congruence, and this one is going to be very helpful to us as we go through the year when we're developing proofs and proving angles congruent or triangles congruent. And that is the reflexive property, the fact that something is equal to itself. When you look in a mirror, you see exactly what is before the mirror. You see yourself or some other person or whatever, but whatever is looking into the mirror, that's exactly equal to itself. So whether it be a segment or whether it be an angle, they're going to be equal to themselves. And that seems rather obvious, but it's going to be very important when we start again looking at proving triangles congruent. The symmetric property I use quite a bit, just a matter of getting things in conventional form. We can take AB is congruent to CD, and we can flip both sides around and put CD is equal to AB. As long as we take the whole side and make it and put it and flip it with the other whole side, we actually have the same thing. And this is really helpful for putting things in conventional form. We've talked about conventions, and usually in our answer we have the variable on the left and the solution is on the right. And so sometimes, depending on how you solve your equation, you may have the variable on the right and the solution on the left, and to put it in conventional form, you would use the symmetric property to flip it around and put it like I said, in conventional form. Transitive property is also very important. It's much like the law of syllogism that we've talked about. Here you have a hypothesis, for instance, and a conclusion, and then here's a hypothesis and a conclusion that are exactly the same. So in essence, you can kind of box those out, so to speak, like we did there, and then what you have is AB is equal to EF. So that's the transitive property. You transfer the congruence of one thing onto another because they're both congruent to the same thing. So again, that one's going to be very helpful, and the one that we use quite often when it comes to proving things. Because if we can show that one thing is congruent, or two different things, excuse me, are congruent to the exact same thing, then it would be the transitive property that would then say those two different things are congruent. So we're going to use this quite a bit, and so we need to get familiar with it. It's very much like substitution. You notice that AB is equal to CD and CD is equal to EF, so instead of CD I can put AB in because AB and CD are the same. So it's similar to substitution, but we'll call it the transitive property when we're working with these. Alright, I'm going to do a couple of examples, and then we'll wrap this lesson up. So I'm just going to show you a couple of simple examples for the transitive property, and then we'll use them more as we go through the year. But here again, we have a statement where angle 1 is equal to angle 2, and angle 2 is also equal to angle 3. So you'll notice that the angle 2 is the same in both. And again, if you think about this like conditional statements and the law of syllogism, here would be a hypothesis and a conclusion, and here another hypothesis and conclusion, and we notice that this conclusion and this hypothesis are identical. So if we reduce those out, kind of like what we talked about, what are we left with? We're left with that angle 1 is equal to angle 3, and the reason we can do that would be the transitive property. Now again, whoops, too far. It's also like substitution. If angle 1 is equal to angle 2, then wherever I see angle 2, I could substitute in angle 1 instead because they're congruent. So I could take angle 2 out and in its place substitute angle 1 because they're equal. So again, angle 1 is equal to angle 3. So that kind of shows you how it's very similar to substitution, but we're going to call it again the transitive property when we're doing that.